Hello, we are here. We are here. Let me mute myself. All right. All right, guys. Hello, world. Hello, world. Siraj is back in business and ready to go. Hi, guys. All right. Hey, everybody. Hello. Hello, Lordius, Jean-Francois, Spencer, Sunny, Jason, Anubhav, Dongo, Lakshya, Pibanwa. Hey, everybody. Okay. So today we are going to play with computer vision. I love computer vision. Computer vision is one of my great joys in life, especially in college. I used to just use OpenCV all the time for side projects, and we're going to use it today. We're going to use OpenCV to take an image. It's going to be a 10 by 10 square. It's going to be a grid. It's going to have obstacles in it. And what we're going to do is we're going to iterate through all of these squares and see which ones are obstacles. And we're going to print those obstacles out by reading in the image with computer vision. And we're going to find the shortest path from the starting image to the image that is matching it, okay? And I'm going to show you guys an image before we start, a little demo after the Q&A, and that's going to be awesome. But first, I'm going to do a 5-minute Q&A like always, and then we are going to get started with the code, all right? So 5-minute Q&A, here we go. And by the way, thanks guys for showing up during finals week. I know it's a busy time. I'm just here to augment your learning experience, all right? Daniel's challenge, yes, Daniel Schiffman and I have talked about collaborating. I'm gonna make a game bot for one of the games that he makes, and it's gonna be awesome. Will you do videos on Watson services? I actually do have a video. It's called what's it called? Build an AI. No, it's called tone analysis, and I use Watson API. What's your target audience? I'm looking to target developers who are between 18 to 60 plus, whatever. Ideally, I want to get kids involved as well. That would be awesome. That makes me really happy when I have like 12, 13-year-olds watching. So I want to expand to kids, but right now it's kind of like college age kids and higher, and high school. Any experience in FIRST Robotics? Yeah, I did. I helped out. I volunteered with a FIRST Robotics competition in New York when I went to school at Columbia. It was awesome. How did you learn all this AI? I studied subreddit, the machine learning subreddit, Twitter feeds, articles, just the internet, and then just a collection of sources. Over time, you get better and better at it. Hey, Siraj, will you cover transfer learning later? That's a great question, Nikhil. I absolutely will. And I think the future of machine learning is in transfer learning. We can't just create a bot that just has to learn everything from scratch every time. And with OpenAI's universe, that's gonna happen faster. We're learning ML with R in university. What do you think about that? I think you guys should switch to Python because R is not as compatible with a bunch of other non-machine learning libraries that you might want to integrate into the apps that you're writing. Where you posted that you are doing live broadcasts. I'm trying to find a spot where I can post that. I haven't really found one, so it's just Wednesdays at 10 a.m. I've kind of not wanted to officially say that because I don't want to commit to doing live every week. But you know what? I just keep doing it, and I love you guys, and I do it for you. So I'm committing right now. Every Wednesday at 10 a.m. is a live session. I might not be on for New Year's or Christmas or whatever. Not that I celebrate. I do celebrate New Year's. It's my favorite holiday of the year because it's a celebration of the future. But yeah, Wednesdays at 10 a.m. are my live sessions. Hey, Siraj, which laptop config for deep learning? Is GTX 1070 good enough? Yeah, any of the GTX series by NVIDIA is a good bet. Would Python and Java be the future of programming? Python is definitely growing very fast in popularity. Java kind of had its heyday, and I feel like it's getting less cool over time. And I also think Go is a language that is up and coming. What are your New Year's plans? I am going to throw the sickest New Year's Eve party at my place. I've invited some YouTube celebs that I met in LA. I invited some, oh my God, it's gonna be awesome. I love New Year's. It is a celebration of the future. Future of Python, as a language, I mean, I think we're going to have more and more abstraction. So things will be easier to do in the future. Hey, Siraj, do you read the White blog? Yes, I love that guy. He is a great writer. As someone who writes an essay basically for my videos, my scripts every week, that guy is a great writer. How do you use PHP and Python in machine learning? Watch my videos, not PHP though. Python is not really a programming language, it's a scripting language, guys. Don't confuse. Semantics, okay? Okay, so I'm gonna answer 2 more questions and then we're gonna get right into the code, all right? Which book do you recommend for machine learning? So machine learning, a probabilistic approach is a great one. Which uni did you go to? Columbia University. Suraj, please say hi, Kartik. There you go. Okay. All right, one more. How to build an AI girlfriend. Okay, so, oh my God. Okay, I've thought about this quite a bit actually. So that would be a generative model, right? That would be a generative model, which a lot of work is going into generative models right now, and it's one of those new exciting fields in machine learning of like not having to discriminate between 2 classes, but to generate something from scratch after having been trained on some data. So building an AI girlfriend would be a generative model, and you want to train it on a corpus of text that a real girlfriend would say, and then it would be a chatbot, a girlfriend-like chatbot. Okay. Do I work for Google? No, I don't work for Google. I'm meeting them like I think next week or the week after that. We're gonna see what we can do, but I'm not gonna just straight up. Okay, I'm not committing to anything, but I'm keeping the door open. Right now, I don't work for anybody. My goal is this, guys. My goal is to continue this channel, make it awesome for you guys. Okay, that's the goal. Okay, so that's it for questions. What are your thoughts? Okay, one more. What are your thoughts on VR and AR? VR, the Daydream is awesome. I just got the Daydream. I got the new Google Pixel phone, and it is awesome. The Daydream is, VR is the future. I can't wait. And also AR. I'm going to make a movie sometime in the future, like an action movie starring myself. So it's like starring Suraj. I'm going to have like AR. It's going to be awesome. Oh my God. Anyway, okay. So, okay, here we go. We're going to get started. What I'm going to do is screen share, and then we're going to get started, all right? Let's get started. Screen sharing time. Boom. Okay, so I'm going to demo what we're going to do first this time, all right? So I'm going to demo what we're going to do first. The first thing I'm going to do is say, this is what it's going to look like, okay? It's better than explaining. It's better to just demo what's happening here. So I'm going to say, run this, run the code of what it's going to do. So take a look at this. You see the image, this is the image we have. It is a grid of squares. And what it is doing, it is iterating through every square in that grid. And once it's iterated through every square in that grid, it's going to print out the coordinates of where the obstacles are. Okay, that's what it's going to do. And it's going to print out, and it's going to look like this right here. Okay, it's going to print the occupied grids and then the planned path. And the planned path is going to be from this initial image, this blue square, and it's going to find the closest image in similarity. Okay, which is going to be like this square right here. And then it's going to show the path between both of them, okay, in terms of X and Y coordinates. So that's what we're going to do, okay? And we're going to use computer vision to do that. All right, so here we go. By the way, tutorials on OpenAI Universe, I'm going to talk with them about creating a video series, so we'll see how that works. Okay, and by the way, guys, I totally want to interview Elon, so like keep that on the DL, but like that's the goal for that interview series. Like I want to work my way up to Elon, so we'll get there. Okay, so I'm going to make this bigger so we can all read it. Okay, so here we go. Here we go. Okay, so we're gonna build this, all right? And it's gonna use computer vision to read this grid of squares, and it's gonna be awesome. Okay, so here we go. You can't see my cursor. That's fine. So the first thing we're gonna do is we're gonna import OpenCV. OpenCV is the library. Yes, Elon Musk. OpenCV is the library for computer vision. Okay, image segmentation, finding objects in images. It is the go-to library for computer vision. Okay, the only problem with OpenCV is that it is hard as F to install. Okay, I would recommend using Anaconda to install CV. So it'd be like Conda install CV. Okay, that's how I do it. But yeah, OpenCV is the computer vision library. Okay, so that's what we're going to use to read our images. The next thing we're going to import is numpy. NumPy is our scientific computing library. Okay, and we're going to use it to perform some matrix math, okay, because images are just matrices, right? They are a collection of ones and zeros. An image can be broken down to bytes, right, bits. Okay, so the next one is importing time, which is going to help us measure how long we are going to run this program for. Okay, so the next import we're going to import, the next library we're going to import is called scikit-image. Okay, and let me explain why we are importing this. So I'm going to import a specific submodule from scikit-image. Okay, it is called SSIM. Now, what is SSIM? SSIM is the mean structural similarity index, okay, between two images. So if we have two images, we need a way of measuring how similar they are. Okay, and the structural similarity index is a way of measuring how similar two images are. So we take two images and we break them down into matrices. We can then see how similar they are by counting the ones and zeros and the positions of each of them, and then having some kind of rough score of how similar these two matrices are. But okay, so that's what we're going to do with that. The next thing we're going to import is a helper class called A*search. Now, A*search is probably the most popular pathfinding algorithm out there, okay? A*search is a heuristic. It is an algorithm that works to find the shortest path between two possible points. That's what A*search does, okay? It's used in games like Warcraft 3 to find the shortest possible path. So what we do is we search among all the possible paths to a solutions, okay? And then we look for the one that incurs the smallest cost. That is the least distance traveled, the shortest time. And among these paths, it first considers the ones that appear to lead the most quickly to the solution. So it's a heuristic. It kind of tries to have an educated guess of all the possible paths, which is the one that is most likely to lead to the exact solution. Weinhafen is exactly right. It's Dijkstra's with a direction. That is a great description. If you know about Dijkstra's algorithm, it is like Dijkstra's but with direction. Okay, so that's what A* is. I'm going to explain more about A* later on when we implement it, but let's get to our next and last import, which is a helper class called Traversal. And that's just like a 5-line of code helper class. It's going to help us traverse the image from left to right for image processing, okay? Those are our helper libraries. Now we can get started and start writing our code. I'm going to get started by writing out the main code, okay? And it's going to take one parameter. What is that parameter going to be? Well, it's going to be the image. Now, let me show you guys the image, okay? Let me show you guys the image. I'm going to go into test images, and I'm going to open one of those test images. All right, so we already have an image. We're not going to construct this image from scratch. What our program is going to do is it's going to read this image using computer vision. It's going to read that image, and it's going to detect where those obstacles are. It's going to find the shortest path between two of those objects, and it's going to list what all of those grids, what are all the squares that have objects in them. Okay, so that's what that looks like. Okay, so anyway, okay, so the next thing we want to do is start writing our code. So to start writing our code, we're going to start off by creating two arrays. The first array is going to be the occupied grids. So we want to create an array so we can store which grids are being occupied in memory. All right, and I'm going to share the image and I'm going to share the code at the end of this video. Okay, so the plan path is going to be and the occupied grids. Occupied grids, not grids, grids. Language is important, guys. Okay, all right. So those are our two arrays, and we're going to store data in them later. The next step is to load the image. Okay, now we're going to load the image. So we're going to say image equals, and we're going to use OpenCV. And what OpenCV is going to do is it's going to read an image. What's the image? Well, we just passed it in as a parameter. It's that file name. Okay. And in terms of machine learning, is this using machine learning? The answer is yes, technically. We are not ourselves implementing a learning algorithm, but OpenCV has used machine learning to train the classes that it's had. So it's indirectly using machine learning from a more abstract layer, okay? So, and I think it's important to do that sometimes. Okay, so so we've loaded our image into memory. Now we've taken that image that I just showed you guys and we've loaded it into memory. It is in RAM. It is in memory, okay? It is just sitting there temporarily. And now we're going to modify it, okay? So we've loaded our image, and we also want to define what the size of that image is going to be, okay? It's going to be 60 by 60 pixels. That's the size of each of those squares, all right? Now we want to create an array of obstacles. So we're going to list those obstacles, and we want a starting point. Okay, so the starting point is going to be the index, which is 1 by 1. That's where our first. That's where our first. We're going to hard code that in. That is where our first object is going to be. It's going to be at the 1, 1 position. And by the way, x, y coordinates are how we're going to view this entire grid. And okay, so yeah. All right, so there's that. So now we're going to create a blank image. We're going to create a blank image, and it's going to be initialized as a matrix of zeros. Okay, so we're going to say blank image is going to get, and we're going to use numpy. It's going to create a matrix of zeros that is of length 60 by 60. Okay, and it's going to be the type is going to be an integer. Okay, so we have to define that. And let's see, I need one more thingy here. There we go. Boom. So that's that blank image. And we're going to, now we're going to, we've got our blank image, and now we want to create an array. We're going to create an array of, we're going to create an array of 100 blank images. Okay, why? Because we have a 10 by 10 square, and we want to initialize blank images that we can then fill in, right? So this is going to serve as a starting point for us. Okay, so we're going to say list images, which is going to be an array, and we're going to say blank image for I in X range 10. So what are we doing here? What we're doing here is, let me explain this in a second. What we're doing here is we are creating a list of images. Okay, we're creating a list of images, and it's a list of blank images. Okay, and so now we want an array to represent in range. Let's see. Okay, so in range 10. So now we're going to create the maze itself. Okay, so now we are going to for I in X range 10. Okay, so now we have our maze. So the maze is it's an empty matrix to represent the grids of individually cropped images. Okay, so we have that. Now we're going to do our traversal time. Traversal time. Okay, so let's go. Okay, let's go down here. So now we're gonna actually start to traverse through our images. Okay, so for each coordinate, the XY coordinate inside of the window, for I in, right, thank you for that. For XY window in the traversal, okay, that sliding window, and let me explain this after I type it. This line's going to be a little long. So we're going to say image step size is going to be 60, and then the window size is going to be the width and the height. Okay, the width and the height, and we've defined that, and they're not going to be that. It's going to be not curly brackets. It's going to be parentheses. Of course, it's going to be parentheses. We love our parentheses. Okay, so what is this doing here? So what we're doing is we are traversing through each square, and we are using our traversal helper class to. The sliding window is the one method that it has, that it just literally it starts from the left, and it slides through a single grid, and it reads it. Okay, and it reads it, and it takes that data and it puts it into memory. Okay, so what we need though is what we're trying to do is we're trying to first. This is what we're trying to do. We're trying to detect the squares that have something in them, that have a detect non-empty squares, because we're going to print those in a second. That's what we're doing right now. So we need to start off by saying, wait a second, if the window doesn't meet our desired window size, then ignore it. Ignore it, because we're looking for a specific type of image. Okay, so we're going to say if window.shape in window size or window.shape, is not equal to window's height, or window.shape is not equal to the window's width, then we're going to continue. So that means we're not going to run this code. Window.shape. So that means it's not the size that we're looking for. So that's just a check. Okay, that's just a check. We're just making sure, like, okay, this is the size we're looking for. But if we have that, let me, right. So we need to 1, 2. We gotta remember our indentations, everybody. This is Python. Ain't no joke. Ain't no joke. Okay, so now we're going to print the index. Image is our iterator, and okay, so now we're going to say take that image and copy it. What does that mean? So now, we've performed our check. We've performed our check, and we're going to say that we performed our check, and we're going to say, okay, if we've got a square, and it's not, it's an actual image with something in it. So we want to create a clone of it, and so that's where the copy function comes in. The copy function will take that image and it's going to put it into this variable called clone. And so now we can format the square for OpenCV. So now that we have that image, we want to format it properly so OpenCV can read it. Okay, so we're going to say we're going to use the rectangle function to define an OpenCV rectangle. And what is a square? It is a type of rectangle. Okay, so line 24, someone said that there is something happening here. They said that boom, I think that's what it was, and then I remove that, and right. Okay, cool. Okay, so now we have our CV rectangle, and we're going to take that clone image that we just created using the copy function, and we're going to say for the XY values, we've created our rectangle, and we want it to be at max. It's going to be whatever the length is of the window, and then we're going to say Y plus window's height, and then lastly, we want to define the entire size of this by 255, 0, and then 2. Okay, so now we've got our rectangle, and so now we can crop that image. We can crop that image, and we can say, well, in order to crop that image, and this is kind of where like a little bit of OpenCV magic comes into play. We want to say, okay, so for that window's width and for that height, we want to create a crop so it's just a. Let me see. So someone said that to change the last X range on line 24 from square brackets to parentheses. The last X range in the, oh, gotcha. Yes, good call. Thank you. Good call. Boom. There we go. So where was I? So cropping images, right? That's so very important stuff. Cropping images. So now we want to say, what's win height? So the crop is not. Right, so I'm going to define how I'm going to talk about how we're going to, get that image. So once we cropped it, we now want to add it to the array of images. Okay, so because this is an image that has something in it. That's all we're trying to do is we're trying to create an image that has something in it. Okay, so we're saying the index of 1. So we're going to, so the list of images, so is an array, and we've created that, and we want to, what do we want to give it? We want to give it the cropped image that we've just created. And how do we give it that? Using OpenCV's copy function, okay? So we've added it to that list of images, and now we want to print the occupied grids. So we can print the occupied grids now, okay? So how do we do that? Should there be a comma between X, Y? Yes, good call. Thank you, Nick. There should be a comma there. Okay, so now we're going to print the occupied grids. So in order to do that, we want to get the average color. So we need to we need to get that average color. So the color is something we're going to use. We're going to create using OpenCV. So we're going to say the color per row. That's how we're going to start off. So we want the average color per row. How do we get that? Well, NumPy has a great function called average. Okay, and how do we get the average? Well, the average is basically taking that image, our cropped image that we just got, and along the 0 axis to get that average color. Okay, and so that's the average color per row. Now we want to get the average color for our specific square. Okay, so np.average. So we're going to take the average color per row, and from that row, we just want the average of what we've already taken, which is going to give us the average color of the square we got. Okay, and so once we have that, finally, we're going to convert that to an integer value. Why are we doing that? Because we need to format it properly for OpenCV to read it. And the best way to do that is to have it be. Thank you, Mick. I think it was Mick who said that, or somebody. No, Geo. Thank you. So now we are going to convert it to an int, uint8, and then and the average color. Okay, so we have our average color of whatever square we're on right now. And so now what we can do is we can, what's the next step? What is the next step? Our next step is to iterate through the color matrix. Okay, we're going to iterate through the color matrix. So we have, we'll iterate through the color matrix. We're going to iterate through the color matrix, and so what we're going to do is we're going to iterate through the color matrix so that we can add it to our array. Okay, np.average. So someone said something about rights. So that is actually parentheses. Thank you. Okay, so if any, okay. So what are we doing here? We are going to say, so if the color is less than 240 for I, so let me explain why I'm using 240 as an index here. In average color, So what we're saying here is check if it's not majority white. If it's not majority white, then we want to add it to our hey, something is here array. Okay, so so to answer somebody's question from up there, how do we know like if images are like all different types of shapes and colors and sizes? How do we know like what type to use? Well, this is how we just say is the image majority white or not, and 240 kind of defines that threshold. Okay, change the uppercase first letter 38. Thank you. Okay, so that's how we're going to do that. And so we're going to say, okay, so maze. This is not the bot for the asteroid game. That is coming up soon. Right now, this is to use computer vision to detect images. Yeah, hold on. So what we're going to do here is we're going to say for maze index 1, 1, minus 1, and then index 0, minus 1. Okay. So I don't need that equals 1. So if not majority white, if it's not majority white, we're going to add it to our maze, and then we're going to say let's add it to our occupied grid array. So occupied grids.append, the append function will add it to our array. That is true, Jordan. Occupied grids.append. And so how are we going to add it? Well, we're going to add it as a tuple. What is a tuple? A tuple is it's not a double. A tuple has 3 values in it, okay? It's like a triplet in music. Wow, I just related music to programming. That's awesome. Okay, so tuple.index. So these are the terms that are occupied. We're iterating through the color matrix, okay? So now we want to, so now we've added the like objects, okay? It's like the blue squares and the red triangles and whatever. Now we want to add the, let me show the image one more time. Let me show the image. Okay, so we've added all of these. We've added all of these. See that? We've added all of those that are not black and they're not white. They're just like red and blue and green. That's what we've added to our array. But now what we want to add are the images that are all black. Okay, and so in that image, it doesn't show it, but there are images that are black, and we want to add those to our array. So okay, so we're going to do the same thing, and this time the threshold is going to be 20 because that defines black. Okay, in hexadecimal, in hex code for colors. Okay, so we're going to take our obstacles array and we're going to append the tuple index. Okay, boom, 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 and so we've done that. And so now what do we want to do? Now what we want to do is say we've appended that. So the next step is to, what is the next step here? It's like, so we've added that. We want to make sure that our image is a tuple. We've added that to a list. Now what can we do? Okay, I've got it. Okay, now we can actually show this iteration. We can actually print it. We've done what we needed to do. And in order to do that, we're going to say image show and the window, right? So this is OpenCV's way of showing whatever we have in our window. But guess what? It's not a continuous thing. It's not a continuous thing. It's just like, if we just did this, if we didn't do anything else, it would just pop the image up for a second. But guess what? We need to sequentially show what is happening. And how do we, line 48 needs a parentheses at the end. Let's see, line 48 needs a parentheses at the end. Yes, good call. And then, and there, and there, and there, and there, and there, and then this doesn't need it. Great, okay. Okay, so that's what we're gonna do. We're gonna show the image, and we're going to say, what else we're gonna do? We're gonna wait a little. ISS, I will marry you for a split second. Boom, we're married. Okay, divorce. Okay, there you go. Dreams come true. Okay, so wait key is 1. And now, okay, so what are we doing? So now we're going to use that time function that we called. And why are we using that time function? We're using that time function to show that, hey, we want to keep continuously showing this image, and we are waiting a little bit. We're going to sleep, and then we're going to keep showing it. Okay. So that's what we use the time function for. So now, okay. So that's what. So what that's going to do is it's going to do this. It's going to let me show what all that code that I just do. It's going to print out the occupied grids right up here. We haven't done the planned path yet. We've just printed out the occupied grids, and it's going to print it out as an array of tuple values. Okay, x, y coordinates. Okay, so that's what it is. YouTube chat is indeed a good debugger. It's not the best debugger, but it is up there for sure. The best debugger is probably like Go's debugger. The Go programming language, man, that awesome. Okay, Lordius is right. I need to slow down and fix some stuff. Okay, so that's what that's going to do. Let me see what these people, what everyone's saying here. So that would be 48, 42, 37, 69. It's definitely not line 69 because I'm not there. Haha. But let's see, 37, 42. 47. So what's happening on 47? So on line 47, let's see. I in average color, exactly. Okay. Okay, so I need to keep going now. Make the variables lowercase first letter, line 38. Right. Right. 47 I in average color for I in average color. Okay, cool. Okay, so now it's time to perform the shortest path search. Okay, so okay, so we did half of it. Now we're going to do the other half. Line 51. For I in average color, if any. Okay. We've done that. So Nikhil asked, why don't we add all the grids that are not white to the array? That's exactly what we did right here, this line 49, okay? So now it's time to perform shortest path. Okay, so let's perform shortest path. So the first thing we want to do is we want to get the list of objects, that we just created. We want to get the list of objects. Why? Because we're going to find the shortest path between one of them and then the one that is closest matching to it. We want to find the shortest path. So we're going to say list of colored grids. Now, this is not the grids that are black. These are the grids that are objects, okay? Right. Thank you, Geo, and multi-shift. Okay, so now we want to say for n in occupied grids, if n not in obstacles. Okay, so now we're going to, so if they're not obstacles, so that means we just want to get the objects. Okay, so we've got that objects, and now it's time to actually do our algorithm. Okay, so for the start, so now it's time. Okay, so for that starting image, so what is our start image? Our start image is going to be this one right up here. You see, hold on. This is our starting image. See this blue one right here? That is our starting image. And what it's going to do is it's going to find the closest image to that, which is going to, because it's going to iterate from left to right. And it's going to do that for every row. And so if it's doing that from left to right, what's going to be the closest, what's going to be the matching image? It's going to be this other blue square. cv.im show correct. Okay, so for start image, in the list of colored grids, so we're going to go through that, and we're going to say, well, we want to define our start image, and we're going to create a temporary array to show that. Okay, start image. Now we're going to say, okay, we'll create another copy of it because we're about to perform some. We're going to compare that image to the next image, and so image 1 is going to be the one that changes. Okay, that's going to be the one that changes. List colored grids to list. All right, so list images into start image 0, -1, and then start image 1, -1. Why are we using 2 copies? That's a great question. We're using 2 copies because we are going to, one of those copies is going to change, right? Because we're going to be iterating through the grid, and we're going to change the value of that copy every time so that we can compute these, the similarity between the 2 images. And we're going to perform A* search once we found the image that is most similar. Okay? Okay. So now our actual so now it's time to hold on. I want to answer a single question because I think it's a really important question. Is it realistic to believe that a new startup can contribute more influential research than DeepMind, or just work at a top company like Google? Yes, absolutely. Why? Because the tools to make machine learning like breakthroughs are, the barrier to entry is being reduced, both in terms of processing power to make valuable contributions. OpenAI's universe is going to make it much easier for the amateur research community to make valuable contributions. And it's really not as hard as you think. Like, it's really not as hard as you think. And I would definitely not be discouraged from working on your own to make valuable contributions. Okay, so I just want to answer that. So now, so now we're going to do the actual iteration for the grid in for n in list colored grids. If n is not equal to the start image. So if it's not equal to the start image, then it's a different image. So we're going to say get that next image. Which is going to be image, and we're going to take that list of images that we already had and -1, and then the grid. Hold on. Grid 0, 1, grid 1, -1. Okay, and there's definitely going to be something make sure I have all of this here. Okay, so now, okay, so here's the fun part. Here's the fun part. Okay, now we're going to convert. So now we have two images, right? We have our original image, and we have the image that we are now iterating through. And guess what? We want to convert that image to grayscale. Why do we want to do that? Let me talk about why we want to convert both of those images to grayscale. Okay, so let me first actually convert them to grayscale using the CVT color function. So we're going to take the image and we're going to convert it BGR to gray. Color BGR to gray. Now we're going to take a second image and we're going to convert that to grayscale. Okay. And right, so both of our images we're going to convert to grayscale. Why do we want to do that? Let me finish typing this out. Boom. Okay. So we have done that. Make sure that there's no lag. All right, great. So now we have, so why are we converting it to grayscale? Well, because grayscale is how, all right, double underscore. Grayscale is, so when we're doing computer vision, we first have to convert those images to grayscale because it lowers the dimensionality of what we are trying to compare. And why is that important? Because colors make an image more complex. They make images more complex than necessary. When we convert an image to grayscale and we compare them by computing some index function, it just makes it faster. It's both computationally more efficient to compare them because it's not about the color. It's about the difference in the positions of the pixels in the matrix. Okay, because that's the similarity. We're not really comparing similarity of color. We're comparing similarity of shape. And so when we convert to grayscale, it makes it faster to compare it. Okay, so that's what we're converting to grayscale. Okay, so now we're going to actually compute that similarity. And how do we do that? Compare structural similarity. Well, guess what? We imported that function, the SSIM function, between both of those grayscale images. Okay. Now, once we have that, so if they are similar, so now that we've compared them, and so guess what? If they are similar, then we're going to perform a star search. If they are similar, we'll search. We'll perform a star search. Okay. And guys, if anybody has any questions, definitely help me out and answer them in the comments. Okay, so how do we say, what's the threshold here? Well, we're going to define 90% similarity, and we're going to define 90% as 0.9, okay? And guess what? That does not have parentheses, okay? Now, perform a star. And guess what? We imported that a star search up there, and if we have time at the end, I'm going to go into this code, and we're going to talk about like the details of the implementation, and I'm going to explain it as well right now. Okay, so what are we performing a star on? On the maze, oh right, thank you. On the maze, okay, that we had, the start image starting at 0, and what is that next image that we have? The start image starting at 1, -1, this is lowercase. And then lastly, we want to say, what are we computing this on? Well, we're computing it on the grid that we've created, -1, because we, and so it's going to take 4 parameters. And I'm going to explain this in a second. -1, okay. So what's happening here? We're performing a star search. What is a star search? Well, a star search is basically us looking at all the possible paths, okay? And then so we are searching through all possible paths, but we are using a heuristic that says what is the one that is most likely to reach the end goal in the shortest possible time. So what is likely to be the shortest possible path? And this is the heuristic we use at every step as we traverse through what we essentially, it's a graph. It is a graph problem. There's not a graph there, but it is a graph problem. And grid is misspelled. Thank you. Okay. So now we've done that. We want to print the result. So we're going to say we're going to print the result. A star equals Dijkstra's with heuristics. Exactly. A star is Dijkstra's with heuristics. So now we can print the result, and we're going to print it as a list. As a list. Please do a video on A star search and also one explaining heuristics and meta heuristics. I think that's a great idea, and I will do that in the future. Yes. Okay. So now we want to print our results because we performed A star, and guess what? We're performing A star in a loop, right? It's not just so we're performing it for every object. It's not just one object. We're performing it for every object that we see. So, and we're going to print the result. It's going to come out in the results, right? So we're going to say, what does the result look like? Well, it's a collection of x, y coordinates, all right, that we're going to get from that first. Oh, okay. So now we're going to append the list, and we're going to add that tuple that we just defined to the list. Boom, boom. And so now the result becomes the list 2, 1, it's 1. Okay. So that's what we have there. All right. Cool. So now what we can do is we can define okay, I think, so there's one more thing we have to do and then we're done. But one more little loop. We're going to say, we want to, if no matched object is found, then we want to return no match. Okay, so it's going to show no match. So in the list of colored grids, we want to say if in the plan path there is if it has the key of the object that we created before, a plan path object list, we want to print no match. Okay, that means that there was nothing there. There was never anything there in the first place. It means our A star search was unsuccessful, and we want to print for that. Okay, so that's it. Okay, boom, boom, boom. All right, so now it's time for our main method. My dad is calling. He's probably like, hey, you're doing good. How are you? I love you. You know, I love my dad. He's a great guy. Well, I think in retrospect, he's a great guy, you know, just like, it's hard to be a parent. Okay, so we've done our code. We can now print the cell in our main method. Okay, if name is main, what is our image file name? Well, we're going to define it right here. Image file name. Image file name is going to be in that test images folder. Test image 1. All right, .jpg. So now we feed that image into it. Right, this is double equals, yes, exactly. And now we'll run our main function on that. That's it. That's it. And now we can run this thing, okay? Boom, main image. Okay. Line 90, use double. Yep, did that. All right. Okay, so what do we do? What do we just do? We created 2 arrays. We iterated through this 2D grid, okay? We said show us the occupied grids. Print them all out as a list of tuples. And then use A star search to find the shortest path between this initial blue and then this one right here, okay? Dude, I almost feel like there's too many lines here. Oh, there's 48, 17, there's a lot. Okay, so let's print this. Let's hold on. Hold on. So I need to delete this. Hold on. Let me force quit that. I'll try again. Check it out. You can see the animation, right? It's iterating through every one of those. It's using OpenCV. It's copying each image into memory. It's comparing them by a structural similarity index. And it's going to print out the list. And the list is going to look like this: the planned path and the occupied grids. Okay? Great, cool. All right. And I'm going to post this code to GitHub. Okay, stop screen sharing. Okay, so I'm going to post this code to GitHub. I'm going to explain it in the README, and I'm going to make a video on heuristics and A-star searches in the future. And it's going to be awesome. And I'm going to end this with another 5-minute Q&A, and then we are done. Okay? Why not draw the path? Says Pro Survivor. That could have been a great idea, and that is definitely something that can be added as a functionality to this code as well. Actually, I'm going to answer 4 questions, okay? So, any undergraduate project ideas using machine learning, preferably sentiment analysis based? Yes, okay? Here's what you do. Use a Twitter API to find some well, first of all, think of a topic that you really want to perform sentiment analysis on. So you want to see what people are thinking about a specific topic, okay? And then use a Twitter API to retrieve a list of tweets about that topic, and then perform sentiment analysis using, to start off, try scikit-learn, okay? Try scikit-learn, and then use, I actually have a video on this. Look at my video called Twitter Sentiment Analysis, and then do that whole idea, but apply it to your own topic, okay? That would be a great undergraduate research project. That's question 1 of 4. We have 3 more. Are those Bose headphones? Yes, QC35s. Have you written any cool ML AI things to help you in your day-to-day life? In my day-to-day life? No, actually, I would love to do that. No, I haven't. Okay, and the last one is, do you have any keyword about 3D path planning? Keyword about 3D path planning. I don't know what you mean by that. A keyword. Will you volunteer to be one of the first people to go to Mars when you interview Elon Musk? I'm definitely going to Mars, guys. I'm definitely going to Mars. It's inevitable. It's something that it's in my 10-year plan. I want to start a new nation on Mars someday. But that's in the future. Anyway, do you believe, oh no, here's a good one. Do you believe AMD will be a big player like NVIDIA in ML? They just showed some benchmarks yesterday. You know, AMD is late to the game. NVIDIA has made so much progress, and it's already not just progress, not just in terms of its computing progress in the chip technology, but also in its partnerships, right, with Google, right? So I don't think AMD is going to be able to catch up to the momentum that NVIDIA has built. And NVIDIA is just a great brand as well, okay? So anyway, that's it for this live stream. Thanks, guys, so much for showing up. I love you guys. For now, I've got to go focus on this video, and I've got to interview this OpenAI researcher for my next interview on Friday. So thanks for watching. Bye, guys. Mwah.